Hello everyone, I am Shilpa Kantekure, Assistant Professor in Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. So the topic for today's session is Playfair Cipher in Network Security. Learning outcomes. So at the end of this session, students will be able to understand basics of Playfair Cipher in network security, and students will be able to encrypt and decrypt a message using Playfair Cipher technique. Contents. So first we will learn the basics of Playfair Cipher, and then we will understand the process of encryption and decryption using Playfair Cipher technique with an example. So the Playfair cipher was invented by Sir Charles Wheatstone in 1854, but is named after Lord Playfair, who promoted its use. It was used for tactical communication by British forces during World War I. It was relatively fast and simple, as it does not require any special equipments. Playfair cipher is a classic digraph substitution technique. Now, digraph means that unlike the simpler ciphers that substitute single letters, Playfair encrypts pairs of letters, that is digraphs. And substitution technique means in this technique we substitute letters with some other letters. So that's why Playfair cipher is a digraph substitution technique. This technique was a significant step forward from monoalphabetic ciphers by encrypting pairs of letters, which makes the frequency analysis much harder for the hackers. The Playfair cipher is an example of a symmetric key algorithm. Now, symmetric key algorithm means the same key is shared with the sender and the receiver of the message. The core of the Playfair cipher is a 5x5 matrix that acts as the key. Now let's see how to create a matrix, key matrix from the keyword. So a keyword fills the first cells of the 5x5 grid, omitting the duplicate letters. The remaining cells are filled with the rest of the alphabet in order. Because the grid is 5x5, so we can accommodate at the max 25 cells. So the letters I and J are treated as a single letter to fit the 26 letter alphabets. Now let's see an example from that how we can make a key matrix from a given keyword. So if the keyword given to us is example and I want to create a key matrix, so the key's unique letters are placed first in the matrix. So E, X, A, M, P, L are placed in the cells of a 5x5 matrix. Now if we observe, there are two E's in the beginning and at the end of the keyword. So the repeating letters are entered only once. Then after we have entered the letters of the keyword in the matrix, we will now fill the rest of the cells with the alphabets in a order. So as A is already covered, so we will write B, C, D. Now E is already covered, so we will write F, G, H. I and J will take a same cell. Then K, after K, L is already placed and M is already placed in the matrix. So we will write from N, O, P is already part of the keyword, so we won't repeat it. Q, R, S, T, U, V, W. Then X was part of the keyword and it is already as its place in the matrix, so we won't repeat it. And then Y and Z. So like this we have prepared a key matrix from the given keyword example. Now let's see how to prepare the plain text. So there are two rules used for preparing the message. So the first rule says we have to split the message into pairs of letters. That is, we have to create the digraphs. If a pair has the same repeating letters, for example, if we take the keyword as hello and we split it into digraphs, then the second pair of digraph will be 2 L's. So instead of writing 2 L's, we will insert a filler letter like X between those two letters. After placing this filler letter, we will regroup the message into new pairs. If the last pair has only one letter, then we have to add a filler letter like Z to the end to complete the pair. Now let's learn about the encryption rules. So rule number 1 says if both the letters of a digraph are in the same row, then we have to replace each with the letter which is immediately to its right. We have to wrap around to the start of the row if in case it's the last row. Rule number 2 says that if both letters are in the same column, then we will have to replace each with the letter immediately below it, and we have to wrap around to the top of the column in case it's the last column. Rule 3 says that if the letters are in a different row or column, then they form a rectangle, and we have to replace each with the letter on the same row but in the other letters column, meaning replacing with letters that are at opposite corners of the rectangle. Now let's understand these rules and how to encrypt a message using an example. So here our plain text is we are discovered and the keyword given is example. So we have already created the key matrix by using the keyword example. So let's go step by step. So first step will be we have to split the message into pairs of letters, that is digraph. So we are discovered, this plain text will be divided into WE, AR, ED, IS, CO, VE, RE and RZ as a pairs. Now our plain text is of 15 letters, which is odd number. So that's why at the last pair we have added a filler letter Z with D. Now these are the pairs. Now we will encrypt one pair at a time. So let's consider the first digraph, which is WE. Now let's locate Now let's encrypt the first pair of the digraph. So this is our plain text divided into digraphs. So let's first encrypt the first digraph, which is W and E. So in this matrix, let's locate the letters W and E. So here is W and here is E. Now both of these letters are neither in the same row nor in the same column. So that's why they form a rectangle, and as per the rule we have to go to the opposite corner of the rectangle to substitute the letters. So first letter is W, so the opposite corner of the rectangle has U. So W will be replaced by U. The second letter is E, and we have to replace this with the letter at the opposite corner of the rectangle, which is A. So that's why WE will be encrypted as UA. Now let's move on to the second digraph, which is AR. Now let's encrypt this. Now let's locate the letters A and R in the matrix. So A is at row 0 and column 2, and R is at row 3 and column 2. So A and R both are in the same column. That's why as per the rule we have to replace or substitute them with the letter immediately below that particular letter. So that's why the letter below A is C, that's why A is substituted by C, and letter below R is W, that's why R is substituted by W. So the encryption for AR is CW. Now let's move on to the third digraph, which is having letters E and D. Let's locate them in the matrix first. E is in the row 0, column 0, and D is row 1 and column 3. So they both are not in the same row, not in the same column. So they form a rectangle, and we have to substitute them by the opposite corner of the same rectangle. So E will be replaced by M and D will be replaced by L. That's why the encryption for ED is ML. So we have to follow the same process for all the remaining pairs. So this is the final ciphertext which we get. So for WE, the ciphertext is UA. For AR, it is CW. For ED, it is ML. For IS, it is KR. CO, it is LR. For VE, it is UX. For RE, it is OA. And for DZ, it is FY. Now let's learn the decryption. Now what are the rules for decryption? So decryption applies the encryption rules in reverse. So whenever we want to retrieve the original message, we have to follow these rules. If both the letters are in the same row, then we have to go left instead of right. If both letters are in the same column, we have to go up instead of down. And for rectangle, the same rule applies for the description as well. Now let's briefly see how to decrypt the first pair, which was UA, and we'll check if we can get the original message, which was WEV. So consider UA. So let's locate these words here. So U is here and A is here. So they form this this rectangle, and we have to substitute these letters with the opposite corner letters. So U is replaced by W and A is replaced by E. So we get the results WE, which is the first two letters of our plain text, that is V. Now what are the weaknesses of Playfair Cipher? Even though Playfair Cipher is more secure than simple substitution ciphers, due to its use of digraphs, modern computers still can easily break it in microseconds. It also cannot directly encrypt numbers, symbols, or other non-alphabetic characters, and there is possibility for manual errors. These are the references used. Thank you.